Section 11.6 and 11.7 deal with spheres, surface area, and volume. So first we'll dig into a little bit more vocabulary. We have a pretty clear definition of a circle. It's the set of all points in a plane that are the same distance away from a given point. That distance, of course, is the radius. A sphere is the same kind of thing, except a sphere is the set of all points in space that are the same distance from a given point. So the surface area of a sphere is 4 pi r squared, and the volume of a sphere is 4/3 pi r to the third power. Please note it's not squared, it's cubed. Now some other vocabulary. The great circle of a sphere is any circle that has the same center and radius as the sphere itself. So those lines of, what are those? Longitude or latitude? Latitude. Lines of latitude are not great circles. The equator is, and lines of longitude are great circles because their radii are the same as the sphere. One more piece of vocabulary. A hemisphere is half of a sphere. So then volume and surface area. If we have a sphere, we know that the volume of the sphere is 4/3 pi r cubed. So the volume of a hemisphere is half as big. Now half of 4/3 is 2/3 pi r cubed. And then for the surface area, we know the surface area of a sphere is 4 pi r squared. So the surface area of the hemisphere will be that dome shape plus one circular base. So the dome is 1/2 times the sphere plus one circle, which we can simplify to 2 pi r squared plus another pi r squared. So to recap, we have 4 pi r squared, 4/3 pi r cubed, the surface area of a hemisphere, 2 pi r squared plus pi r squared, and the volume of a hemisphere, 2/3 pi r cubed. Let's next work a few examples. Take a minute, get this in your notes. We want to find the approximate surface area of a sphere that has a great circle with a circumference of 18. First, let's do a quick sketch. We've got our sphere. You can draw a big circle and then kind of put a belt around it. And our goal is to find the approximate surface area. So surface area is 4 pi r squared, which means we'll need the radius. We're given the circumference, and from the circumference you can kind of back out the radius from the circumference formula. So we'll divide by 2 pi, and then you can simplify that fraction. We know the radius is 9 divided by pi. So we'll sub that into our surface area formula. 9 divided by pi squared is 9 squared over pi squared. And I see I've got a pi divided by pi. And so the exact surface area would be 324 divided by pi square millimeters, or in approximate form about 103.1 square millimeters. Ready for the next example? Here we go. We want the exact volume given the diameter. So exact volume, of course, is 4/3 pi r cubed. We know the diameter is 8, so that means our radius is 4. And all we have to do is sub in the value of 4, cube it, and then make sure you see, hey, we're doing cubic centimeters. Now this would be considered the exact volume. If you wanted the approximate volume, you'd pull out your calculator and sub in 256/3 pi to get whatever that is approximately. Another example, a hemisphere has a surface area of 192 pi square centimeters. How big is its radius? So we've got a hemisphere, and the surface area is given. Now remember, surface area is the dome plus a circular base. So 2 pi r squared plus pi r squared, which simplifies, of course, to 3 pi r squared. We'll sub in the surface area and solve for the unknown. and then we'll sub that in, and we're good to go. All right, one final example. We have a sphere with a given volume, and we want to find the area of its great circle. Now, area of a great circle, that's just the regular pi r squared. That's a two-dimensional surface area. And we are given the volume. So volume is 4/3 pi r cubed. So the connection between the blue and the green there is the radius. So we know the volume. I'll turn that into an improper fraction, 500/3 pi. I see on both left and right side of the equation I've got a divided by 3, so I can multiply both sides by 3. And that simplifies the algebra a bit. Divide by 4 pi to isolate the variable r cubed. And then to undo a cube, you use cube root function. So we have a radius of 5. And then all we have to do is sub that into our area. And we see we have a surface area of 25 pi square units.